Hello, welcome to my mole math video. Before I begin, I want to review some things. 1. What is mole math? Mole math is a standard scientific unit for measuring large quantities of very small entities such as atoms, molecules, or other specified particles. 2. Why do we use mole math? We use it so it makes calculating larger quantities easier and faster. 3. What units do we use in mole math? We use the following units: grams, moles, atoms, particles, and molecules. 4. What kind of math do we use? Basic multiplication, division, and a basic understanding of exponential numbers. 5. Is it similar to anything I might know? If you know how to do dimensional analysis, then this is pretty similar. But what if I don't know how to do dimensional analysis? Or, I don't know what dimensional analysis is? Well, dimensional analysis is the analysis of the relationships between different physical quantities by identifying their base quantities and units of measure and tracking these dimensions as calculations or comparisons are performed. That's a very quick Mole Math 101 intro. Let's begin, shall we? Okay, so the question is, how many grams is 3.6 to the power of 24 molecules of carbon? 1. Let's highlight all of the important information. We can circle 3.6e24 molecules and carbon. Using this information we can determine our starting and ending point. Our starting point is 3.6e24 and our ending point is the answer. Now that we have located that information, we now have our conversion factors. In this case we know we can't go from molecules to grams. We have to go from molecules to moles, and then moles to grams. As for why we can't just simply go from molecules to grams, well, it's kinda impossible. Each molecule has its own respective mass, so the unit of moles acts like a balance point between the two. However, there is a number that is used to convert molecules to moles, Avogadro's number, 6.022e23. That will help us get there. Then we have to find the molecular mass of carbon, which can easily be found on a periodic table. The molecular mass of carbon is 12 grams. That will help us go from moles to grams. Now, we can set up our mole math. Since 3.6e24 is our starting point, we can put that on the top left hand corner. As for the denominator, we can leave that alone. We also put molecules next to 3.6e24, since that's the unit attached to it. As stated previously, we need to go from molecules to moles using Avogadro's number, 6.022e23, in order for molecules to cancel out, so we can move to moles. Next, in order for these to cancel out, we need to put 6.022e23 on the bottom center column, and then we put 1 mol on the center top column, for the next step to be possible. Since there is now molecular units on the top and bottom, they can now cancel out, and we are now left with the remaining numbers. We can now move from moles to grams. Now, the 12 grams can be placed on the top, since we can't place grams on the bottom, because that's where the other mole would go to cancel it out. Then we put 1 mol on the bottom. After we cancel those out, we are left with the remaining numbers, 3.6e24, 6.022e23, and 12. With the remaining numbers, we can rewrite our equation, so on the top it's 3.6e24 times 12 over 6.022e23. To make things simpler, we can subtract e24 from e23. So, we are now left with 1e, which equates to 10. So our new top is 3.6 times 10 times 12 divided by 6.022. 3.6 times 10 times 12 equals 432. 432 divided by 6.022e23 equals 71.736965. But we can round that to 72. So the answer is approximately 72 grams. So, to end this off, there are 72 grams and in 3.6e24 molecules of carbon.